All right, so this unit we're going to be talking about some derivatives of some kind of different functions. And so today we're going to talk about how do we find the derivative of e to the u and a to the u. Now remember that e is just a number, 2.71828, and the thing of it is it actually came from a limit. Is that back in the day, there were mathematicians that were looking at this limit right here, and it kind of came up with this weird number, and so they gave that number a name. And so that's where e comes from. Now here's the thing. Really, when it comes to taking the derivative of e to the u and a to the u, you're going to have to just commit some things to memory. It is straight formula. And so the derivative of e to the x is actually e to the x. And I won't derive that, but if you think about the graph of e to the x, it kind of looks like this. And if you think of the tangent lines, well, it's close to 0, and then they just get steeper and steeper and steeper. So if I drew lines if I drew an f prime graph, okay, well, it's going to be close to 0, and then as I move on, it gets steeper and steeper and steeper. It kind of makes sense graphically that its own derivative, which is kind of a weird thing. So the derivative of e to the x is just e to the x. But what happens when this exponent is not just x? As we've done many, many times, you have to really, in a sense, memorize this one because it says that the derivative of e to the u, where u is some function of x, like x squared or x plus 2 or something like that, it's e to the u times u prime. And as you know, I'm a words, so I'm just like copy, and this is the derivative of the exponent. And so when you look at e to the x, well, it's really the same formula, because if I copied it, the derivative of e to the x is e to the x, and the derivative of my exponent is just times 1, that obviously you don't do times 1, or to write that, and so you just get e to the x. So let's do a couple examples, and then I'll get to what if the base is not e. So let's look at this one. So when I want the derivative of e to the 6x rather, my derivative, it's just this fast. I copy times the derivative of the exponent. What is the derivative of 6x? And of course that is 6. And as you get faster and use it, yeah, I probably put that 6 out in front. Make it look a little prettier, and that's my derivative. Pretty quick. Example 2. Let me look at that. Let me write that. Let me think about what my formula is. I see e, that's to the power of -3 over x. So I'm like, all right, well, I know I'm going to copy it. So I have this times what? Times the derivative of the exponent. So let's think about what the derivative, how could I write -3 over x? Probably smart for me to write it like that. That's what I need to be thinking about, and that's what this u prime is, the derivative of the exponent. So this derivative, power to the front, that would be 3. Decrease the power by 1, that would be x to the -2. And then they usually, again, don't write the answer with negative exponents. So I would have a 3 on top. I would have an x squared on bottom. And then I would have e to the 3x on bottom. So that's one way to write that. So hopefully you're kind of seeing the idea. I'm going to go ahead and do example 4. I might as well, because it has an e as well. So I'll go along with that. f prime is going to be copy. And then I have to think, what's the derivative of the tangent of 4x? Well, we have to remember the chain rule. Okay, don't tell me the derivative of tangent of 4x is just secant squared of 4x. That's a part of it. It's secant squared of 4x times 4, because this is layered as well. And so, yeah, I'll put the constant out in front. Doesn't matter which order you put those things in. So as you can see, it's just a matter, this unit is a lot of formulas that you're just going to kind of go straight formula, but you do have to remember all your other rules as well. Now, what happens if the base, all the ones we just did, notice that the base was E? Well, what happens if it's not E? What if it's 5 or 2 or 3? Well, there's one extra piece. And that one extra piece, if you look at the derivative of a to the u, so again, u is some function of x, but a is a constant. So what really goes on is the same thing, copy. This is still the derivative of the exponent. And then this is the natural log of the base. So you just have to add that in if your base isn't E. Now some people would go, you know what? I'm going to memorize, listen, every formula that you just said, I could memorize this one and it covers them all. And you would be exactly right. Because think about this. If I did copy derivative of the exponent and I put in a natural log of the base, well, if my base is E, what is the natural log of E? 1. So that's why this part, again, you just don't write it. So I want you to see that this is, although I have them typed as 4 different formulas, it really is one formula. And you literally could memorize this one and it would cover them all. So when I look at example 3, my brain, as I'm doing this derivative, I say in my head, copy times exponent of the base, excuse me, I just said exponent of the base, derivative of the base, okay? I'll be honest, it's like 5 o'clock in the morning right now, so I'm a little tired. But anyway, so I have copy times the derivative of the exponent and natural log of the base. There it is. And that would be my answer. Now, as far as how you leave your answer, again, if this is on free response, they would give you that, etc. You have to remember, if you remember at the beginning of the year, we talked about log properties. If it's on multiple choice, you have to find the answer that's there. So I'm just going to warn you and remind you that remember the log property that says if you have a coefficient in front of the log, where can you move that? You could move that to be an exponent on the base. So these two things say the same thing. And of course, if I do that, well, 5 cubed is 125. I'm not saying this is a better answer. I'm just reminding you that if by chance they used a log property, you're going to have to be able to get to the final answer. And I just wanted to remind you of that. So anytime, kind of like when you have trig identities, you kind of have, when you have trig in the problem, you have trig identities in your pocket because you never know what they might do. Well, when you have logs, same thing. You very well might have a log property that you have to use. All right, now let's do the backside. As I go to the backside, you're going to have to, again, you have to remember all of your other rules and do those rules amongst learning this new derivatives of e's. So let's look at example 5. Now, I hope the first thing you see when you look at example 5 is, oh, I have two variables that are multiplied together. That is x times e to the 2x. So the first thing you have to make sure that you do is you have to be doing the product rule. And if you're not, then there's no way to get it. So I'm going to take this as the first and this is the second. So the product rule says first times the derivative of the second. So how do you get the derivative of e to the 2x? And now that we've done it a couple times, it's going to be e to the 2x. So you copy, times the derivative of the exponent, which is 2, and I'm going to just slap that in front. First times the derivative of the second, plus the second times the derivative of the first, which of course is 1. You don't have to write that. And there again, kind of same song, is multiple choice. I'm just thinking of all the math they could possibly do, just to warn you. They could leave it extended out like that. These both do have an e to the 2x. So if they want to make you do more math, as sometimes they do, they could write the final answer that way. Why don't you try number 6? Good old quotient rule. Let's look at it. We got ho, d high, the derivative of the high. That's going to be 3e to the 3x. Ho d high minus high d ho. What's the derivative of that denominator? Well, the derivative of 1 is 0. The derivative of e to the x is e to the x all over ho ho. So that's the denominator squared. Don't you dare cancel. Okay, this and this, don't do that. You can't do that because of a minus. Now again, at this point you're going to see, or you're going to look at, okay, they're going to clean up the answer. So let's do a little distributing on the top. I would have 3e to the 3x plus, remember when you multiply things with the same base, you add the exponents. So I would have 3e to the 4x, since x plus 3x is 4x, minus, and in the same way, this would be e to the 4x. And that denominator, they usually don't multiply that out, so I'm just going to leave it that way. And then I can add like terms. So I would have 3e to the 3x, and then I would actually have 2e to the 4x's all over 1 plus e to the x parentheses squared. And that would be my derivative. And then finally, this last one, again, now you've done these problems before. It's just that I can now throw e's in there. So I've got to remember the constants, and I've got to remember throughout this problem when I'm doing implicit, and I've got to remember the product rule, and I've got to remember implicit. So I got to just think through everything that I've done. So I'm like, okay, here I go. How is it that I am going to find, of course they put this one first, which is the hardest one. What is the derivative of e to the u? You copy. Times what? The derivative of the exponent. Now the exponent is a product. So I have to do the product rule. So I'm just looking at the x times y. First times the derivative of the second. So the derivative of y is 1, but with implicit, remember, I'm taking the derivative with respect to x. So anytime I take the derivative of y's, I have to have dy dx. So first times the derivative of the second plus the second times the derivative of the first, which is 1. And then the rest are a little bit easier. The derivative of x squared is 2x. That one's not bad. And the derivative of negative y squared is negative 2y dy dx. And of course, again, I say the constant because a lot of people mess up right in this step. They put 10 over there. I'm taking the derivative, so that is 0. Now remember, after that, we want to collect our dy dx's, but I would do a distributing step because I got to get rid of these parentheses. So let's go to my next line and do x times e to the xy dy dx plus y e to the xy, yucksy, plus 2x minus 2y dy dx equals 0. Now look what has a dy dx. So I have this one and this one. So what I'm going to do is I'm going to keep those guys on one side, and I'm going to move that which doesn't have a dy dx to the other. So these two terms I'm going to move to the right. So I would have negative y e to the xy minus 2x. And if I only have the greens on the left, then I could factor a dy dx, and I would have that left. And of course, my last step is to just divide. So what would I get for dy dx? Dy dx would be negative y e to the xy minus 2x over x e to the xy minus 2y. And again, for multiple choice sake, I want to remind you that an equivalent fraction, because if you think about factoring a negative 1 out of both the top and bottom and then canceling, is if every sign of every term is opposite, then you have an equivalent thing. Because if you didn't see your answer but saw this on the answer choices, you would need to know that that was the same thing and not think, oh, I did it wrong. You just have an equivalent thing. So there is your lesson on the derivatives of a to the u and e to the u. Remember, it's copy, derivative of the exponent, natural log of the base. All right. Good luck, everybody.